let's go. Maximum fruits harvested after at most k steps hard. Fruits are available at some positions on infinite x-axis. You're given a 2D integer array of fruits where fruits of I is positions of I and amounts of I. Depicts amounts of I fruits at position I. Fruits is already sorted by position in ascending order, and each position is unique. You're given integer start position and integer k. Initially, you're at the position start position. From a position, you can walk either left or right. It takes 1 step to move 1 unit on the x-axis. You can walk at most k steps in total. For every position you reach, you harvest all the fruits at that position, and the fruits will disappear from that position. Return the maximum total number of fruits you can harvest. So here there's 8, 3, and 6 at positions 2, 6, and 8. You can move 4 steps. Starting at position 5, you go 4 steps. You could actually reach step 9, but that doesn't give you any more fruits. But if you go upwards in 5, you get to harvest 3 and 6. Yeah, okay. Here, then you can move 4 steps, and basically you take 1 step left and 4 steps, and 3 steps right, or you can even do 3, no, it has to be 1 step left and 3 steps right. You can't do 2 steps left and 3 steps right. Okay. So yeah, I started this a little late just now, but it's gonna be alright. I think the thing here is I'm pretty sure you can either optimally, using your steps, move in one direction, or move in exactly like one direction and then turn around exactly once. It doesn't make sense to move multiple, like move left, right, then left again, because you're kind of wasting steps. And in particular, if you were to move left and then right, or right and then left, you have to move a smaller amount to one side first, and then a bigger amount to the other side. So like here, you're moving 1 step left and then 3 steps right. It doesn't make sense to try to do 2 steps left and then, or 2 steps right and then 3 steps left. And so optimal coverage of positions would be either go in one direction only, or go in one direction x steps and reverse direction y steps where x is less than y. So then, okay. So then I think it's just a matter of seeing, like this thing, like you can quickly identify how many fruits are done with this. This gets all fruits that are, let's say P is my current position, in like P to P plus K, where K is the number of steps, or from P minus K to P. So if P was, let's say, position 100 and K was 50, I go like 100 to 150, or 100 minus 50, which is 50 to 100. I think maybe using 50 and hundreds. Like P is 100 and K is 25, 100 to 25, 75 to 100. So and then this one, this is also, I think, maybe pretty reasonable. So what is the kind of folding result here? If I fold the string, what the string is of length k. So I think this goes 1, 3, or it could go 2, 2. If this is like 100, then it goes 199, 298. 298 would be 90. No, let's see. Let's say I start position 0, but -2 with positive 96. So each step you go in one direction, you lose the ability to go 2 in the other direction. So it's going 4. If I go 1 this direction, it goes 2. If I go 2 in this direction, it goes 0. Okay, so each step in one direction loses 2 steps, 2 in the other, 2 in the maximum case of the other. I guess that makes sense because you're backtracking, kind of. So it would be something like, so if you have k, I think it goes something like k, one direction. Let's say I go x in one direction, then it'd be like my position minus x, and then my position plus y, where x plus 2y equals x plus 2y equals k. Is that right? That's not right. There's no way that's right. 2x plus y equals k. So it's 1. Yeah, I think that's right. Okay, so it goes 1 in the left and then 2 in the right. 2 times 1 plus 2. Or it could go 2 to the left and basically 0 right. So 2 times 2 plus 0. Okay. So what does that mean? How would I compare those results? Is it a sliding window? So the window, you start the window maybe fully on one side, and then start the window fully on one side. So let's say you go strictly right. So from that number that you're at to that number plus k. And then your choices would be, you would need to remove 2 from the right to get 1 on the left. I think so. If you just remove 1 from the right, then you don't get anything from the left because you're backtracking. So let's see. You go 4 here. If you just go 3 here, yeah, actually, you have to move much more than that. So if you go 4 to the right, so 5 to 9, if you want to actually start covering something on the left, you have to start going up at most 7. At most 7. Because at that point you're just breaking even in terms of getting back to where you started. Okay, so maybe that's not really. So you go all in one direction with no backtracking, or your window slides Or, okay, say it's something that's within half of k on either side. Yes, half of k on either side is the most that you can kind of work with when you're backtracking. So it'd be something like, let's say k and half k is h. H is half k, so k is 4, h is 2. So it could be something that's like 2 to the left and 0 right, or h minus for every increment of 2 less than h, then you can get one additional thing on the other side. So if h is, let's say, 100, then you go to 98 on one side and 1 on the other side, or 96 on one side and 2 on the other side. I think that's right. And then you can probably do a sliding window of that, can you? Maybe not a sliding window. Maybe you can do something like so I wonder if you can just do, do you need to sort it? No, I think you do one pass to find it, I guess. Like just a single pass to find all the values and then just find the biggest value while keeping track of that. Yeah, okay. Alright, enough thoughts. Let's go ahead and do this. Find total opposite harvest. So find harvest going in one direction. I wonder. I think I need to do a prefix array actually. Yeah, this should be the first thing. So prefix array to get sum to quickly get sums between indices. And hopefully this is going to be 10 to the 5th. Yeah, this I can do a prefix array here. So this array starts with just an empty array, I think, or starts with 0. It starts with 0 in the array. And then for every value in the sort positions, actually this is going to be kind of annoying. Yeah, I guess that's still fine. Okay. Normally you have another value that's like fully there of like fruits at every position. This is going to be kind of scattered amounts at various positions. So let's go ahead and use I think maybe I can still use the fruits. So let's say the fruits is positions comma amount. Okay, so position amount in the fruits array. If there's, let's say, 5 fruits at position 1, then what I'll do is I'll take the previous sum or prefix at the position, or position plus 1. Maybe it's position plus 1 is equal to, I think I need a current sum. Yeah, I think I need a current sum. Actually, this prefix array needs to be completely there. So, I think the biggest position is just the last position fruits. So let's say, in this case, I'll use n position is equal to prefix or the fruits at the last, and then the index in position of that. And the prefix sum is essentially 0 at all positions. So 0 times n position plus 1. So if the last position is Yeah, if the last position is listed by 5, then I want 6 spots. And I want a current sum, which is the sum of everything up to this position. So prefix, shucks. I would literally need to go through all positions at that point. I need to go through all positions. Otherwise, it's going to be just spot values. It'll be a single pass of 10 to the 5th, I guess. It'll be a single pass for 10 to the 5th. I might fix this for a array that's sparsely filled later on, but right now I'm going to fill it completely. So I think that means I need to just have 2 separate pointers. So for every index in range of positions, actually, yeah, this should probably be the position. And I'll have an index into the fruits array. Maybe I'll call this bin fruits index. Okay, so how is this going to work? If the position is equal to the current fruits at this index at that position, so the current sum should increment by the number of fruits there. And then I store the current sum into the prefix array. So the prefix, at that point I could probably just use an empty array and append, since I'm going through every position at this point. I guess let's just start with 0. 0 always has 0. Yeah. So prefix dot append current sum. Actually, at that point, I can maybe I can do if else also. So yeah, I don't need the current sum if I just append it to whatever is previously, or add it to whatever is previously there. Alright, this is fine. I'll consider removing this current sum variable. Yeah. Okay, I'll just do prefix dot append whatever is currently at prefix last value, and prefix dot append prefix at the last value plus fruits. Yeah. This is the same as current sum without using a variable for it. And I do need to increment the index every time I see a fruit that is actually at this position. Okay, let's go ahead and just do a quick sanity check here. And see if it's correctly giving the prefix sum array. So position 2 is 8. So position 0, 1, up to 2 is going to give you 0 for the sum of the fruits up to that point. 6 is 3, so this is blank, 0. The reason why you have an initial blank is if there was some number of fruits at position 0, let's say there was 5 fruits, what you want to do is you want to take that I think you want to take that position plus 1 minus or from that index minus the number of positions that you're at. For some reason there should be a 0 at the start. I forget why. So 0, 1, 2, 3, 4, 5, 6. So at position 6, 11 minus, yeah, so this is position 6. This is position 0. Yeah, you can take the difference between the position that this is 6 minus some number of them, minus some number of positions before that, and the difference of that. The difference in the values of those positions should be the sum of the things that you can gather between. So 11. Oh, this is not great. There should be one more. Maybe this should be position plus 1. Yeah. I think that's right. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, the last one is should increase the total by whatever the last root position is. Okay. Okay, and here I'll do the trivial cases. Find totals for, I want to use the word harvest. Find harvest values for going strictly left or strictly right, or when only left, or because if you don't do any backtracking, you can go farther out than if you do some sort of backtracking. So answer equals the maximum of, if you go strictly left from your starting position, it'd be starting position 0 indexed. I think it is, right? Yeah, starting position is 0 indexed. So I think it's starting position plus 1. Actually, so say harvest left is equal to prefix sum from start position plus 1 minus prefix sum at start position plus 1 minus k. So if start position is say 5, k is 1, yeah, that's right. Harvest right is equal to prefix sum of start position plus 1 plus k, I want to say, minus prefix sum start position plus 1, start position plus 1. Is that right? The start position is start position plus 1. The start position is 0 and k is 5. Yeah, I think that's right. Okay. Which is a little weird. When would you ever have start position of 0 used in your prefix sum? Okay, actually, yeah, you could actually have like start position is 1 and you go 2. Actually, could this go out of bounds? This could go out of bounds, right? Fuck. This could also go out of bounds. So I need to cap it or for it. So this thing, the minimum start position here is 0. The minimum of this thing is 0. And the maximum of this thing, actually that's not how you do it. It's the first maximum. If it's a negative, then you want to just use 0. So this should be minimum. of this position and the last position in the array, which should be n position plus 1, I want to, or is it n position? I think it's n position. Yeah, and I'll print out those two values. So answer is the maximum with that. And let's see how this goes. Okay, so starting at position 5, the maximum you can go for leftwards is 8, rightwards is 9. Uh, 8 and 3. This is not including the 6, correct, I guess. That's not great. Okay, so 8 and 3. Go ahead and print out the prefix sum again. The n position plus 1. So start position is 5. 5 plus 1 plus 4 should be 10. 10, and the number position was 8. It should be 9. I think that still is inbounds. Is that the biggest position? Okay, it doesn't really say what the biggest position is, but in practicality it should be 9. So starting position 5. Yeah, okay, so 5. Starting position is 5 plus 1 plus k, which is 10. But because 10 is equivalently 9, let's see, start position 5 plus 4. Zero, 1, 2, 3, 4, 5. From this thing, 4 more than it inclusive. So 5, 6, 7, 8. Position 5 is index 6. 5, 6, 7, 8. Which is position 9. 9, or position 9, or index 9. So it's 5 plus 4. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So maybe I should just use start position plus k. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. Start position plus k. And then minus. And that should be capped at n positions, which is 8 plus 1, 9. And then I should just subtract current position, which should be start position, so it should be minus 4. So 0, 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, if that's right, then did I screw up on the harvest left as well? If I want to say there's something at position 0, I'm using k equals 1. I think maybe I see maybe k is always actually +1 as to the number of things I'm taking. If k is 1, then I'm actually taking 2 things. Okay, maybe that's why I'm getting so confused. But then the difference between the start position plus k and this position is going to be just k. But I want to have 2 things that would be gathered, right? Yeah, so what? I want to have 2 things that are gathered. So if the position is 1 and k is 1, then I would be subtracting from this position 0, 1, 2. Start position should be +1. Start position should be +1. Start position minus k actually. So if I do start position is 1 and k is 1, then I should be taking everything from this spot all the way to 0. Okay. And then start position is 1 and k is 1 going upwards, then I should be taking everything from here going to here. Start position plus k to start position minus 1. Position minus 1. I think so. Yeah, if like start position is 0 and k is 1, then I should be taking it from here to here. Okay, I think this is 8, 9. Okay. Okay, let's see what's going on here. Start position is 5, k is 4, so 5, 1, 2, 3, 4. So going leftwards, I should just get 1. Going rightwards, no, sorry. Leftwards, I get 7 and 1, so I should get 8. And then rightwards, 7, 2, 4. 1, 1, 2, 1, 2, 3, 4. So 8 versus 13. Oh shit, 8 versus 14, did I add this wrong? 7 plus 4, yeah, I did it wrong, so that's 14. And then the last one here should be zeros. This k is 0, so I can only harvest the things at this spot. So let's go ahead and just do a quick test cases here. Let's add a 0, 3. Start position is 3. So let's say I add something at my spot. So 3 position, there's 10. Wait, this is 2, huh? Does k have to be at least 1 step? No, k could be 0. So let's go ahead and test case where I duplicate this and say that there's some initial values at this position. So let's say at position 3 there's 10, and I'm actually going to limit this to k equals 0. So I should be able to get 10 going left or right. Oh, that's wrong then. Fudgebadoodut. Okay, so why is this one wrong? So position 3 going leftwards is correct, it's 10. And then position 3, 0, 1, 2, 3. I think maybe it should be k plus 1 here. Or it should be plus k 0. Gosh dang it. Start position plus 1, start position minus k. Start position plus 1 plus k, and end at start position. Yeah, I think that has to be the play. 10, 10, 8, 9, 8, 13. I think that's still the same. Okay. All right, so let's go ahead and just move it around. Let's say that it's position 4 for the fruits are. I can move 1. So this should mean I have harvest left of 0 and harvest right of 10. 0, 10, okay. And let's do an edge case where I go to the very edge. So this one goes to 4 steps, right? So 0, 1, 2, 3, 4 steps. So if I go 5 steps here, I should gather the 9. 0, 1, 2, 3, 4, 5 steps. And if I go 5 steps, I should also gather the 9 on this side. So duplicate that case, go 5 steps. And that should be 9 more than what was previously there. Previously there was like 8 and 14. So 9 plus 8 is 17, 9 plus. That's not correct. 22. That should be 23, no? 7 plus 2 plus 4 plus 9. What did I do? What happened there? Seven plus 4 plus 2 plus 9. 22. What am I doing wrong here? 1, 2, 3, 4, 5. There should be only 23. But even the thing says 22 on the expected results. What? 32 minus. How is it getting 22 at all? Okay, so start position is 5, k is 5, so it would be 5 plus 5 plus 1 is 10. Oh, so plus 11. And at most there's end position is 10 plus 1 is 11. So 11, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 32. My start position of 5, 0, 1, 2, 3, 4, 5. It's 22. 7, 2. Oh, wait, am I? 7, 2, 4. What is going on? 7, 2, 4. That gives you 14. If you do 23 minus 10, that gives you 13. 724. Am I not subtracting the right one? Should be 23. 1, 2, 3, 4. Yeah, I should be subtracting a 9. I really don't even know how you get 22 here. You start with 5 from 5. So here, 5 is going to be position 5. I wonder. For every position you reach, harvest the fruits. So you can harvest the fruits at your position, I think, right? If you're if you're just standing there and not moving, you can still harvest that, right? Correct answer here was, oh shit. Correct answer here should have been from starting at position moving 0 times. The correct answer should have been 10. Yeah, okay. Five plus 2 plus 4 plus, I don't even know how you get 22. You should be able to get 23. If you move 5 steps to the right. 1, 2, 3, 4, 5. You should be able to get 7 plus 2 plus 4 plus 9. 7 plus 2 is 9. 9 plus 9 is... What? 7 plus 2 is 9. 9 plus 9 is 18 plus 4 is 22. 7 plus 2 plus 4 is 14. 14 plus 9 is 23. No? Oh my god. It's 13. It is 13. Oh my god. In that case, the other one was incorrect, maybe? Or maybe I did some... Okay, so there was a point where I calculated correctly, I got an incorrect result, and I changed my thinking to miscalculate. So, okay, I think I recognize the pattern of mistakes here, finally. So this thing, if I test case this to be, let's say, which test case was it? Test case 2. Okay, it was 13. Okay. Initially I saw 14, I thought 14 was the correct answer until I just redid my math incorrectly. Okay. Whew. So those are the initial correct values. And then I just need to find the maximum of moving it kind of some number left and some number right, backtracking. So for every number of steps in one direction, so it needs to go to half of the number of k. Half the number of k is the most thing you can do. I think doesn't really make Is there some optimization here? So the only things that get better is if you do 1 to one side and okay, actually I don't think it for D in range of 1 to 2 k divided by 2, I think, where D is the number of waves, number of steps in one direction. I can do something like harvest left is if I go D in left direction first. God damn, these positions are hard for me. Prefix. So it's gonna be okay. Let's think about this in one of the test cases, and hopefully it works out. So my initial position is which test case do I want to use? Position in example 2. Okay, so example 2. My distance is 5. 0, 1, 2, 3, 4, 5. I think I should be at the 10, is that right? Yeah, I think I should be at the 10 because the sum of everything up to this thing is 10. Well, no, if I'm in position 5, I should be at the 16 or the 17. So I should be at the 17, so it should be start position plus. So my position is start position plus 1. So start position plus 1 is my default, plus if I go 2D, more than that. So if D is 1, then I can go 2 more than that. Yeah. And then start position. So it should be, I should be here, thinking about going 2 here, and then the difference between them needs to be k pretty much. Then that's the same thing as, no, not the difference between them, k, that's wrong. But it should be basically be 3, 1, 1, 2, 3. 3 spots or 4 spots. The width of this thing is 4 spots. So I should be subtracting 4 here. How am I subtracting 4 here? What the fuck? 1, 1, 2, 3. I should be subtracting 1, 2. No, it should be 3 spots. Oh my god. It should be ending up at something that is above the 4 increase. Above the 4 increase. So this spot is fine. 21, 2. Start position is 5. 0, 1, 2, 3, 4, 5. Oh god. Start position minus D. It's either like plus 1 minus D, minus 1 minus D, minus D. So if I just did 1, that includes the 4. No, that doesn't matter. So start position is going to be 0, 1, 2, 3, 4, 5. I need to include this thing. Start the position minus D might work. So K is 2. Oh, that doesn't make sense. For every 1 that I go in this direction, I go 2 less in the other direction. So if I go 1 here, I go 2 less in the other direction. If I go 2 in this direction, then I go 0 in the other direction. So it should be K minus 2D. Start position plus K minus 2D. I think. Oh boy. I need to cap it as well. Okay, let's not worry about capping. Start position plus 1 plus K minus 2D. Start position is 5, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. But I need to start position plus 1, I think. Plus K minus 2D, plus K minus 2D in this case is 4 minus 2. 4 minus 2 is going to give me 2. So if I have 5 plus 1 is 7, 6, 0, 1, 2, 3, 4, 5, 6. 6 plus 2 is 8. So I'm here, which is the correct spot to be to start the subtraction. And then 6 minus D would be 5. No, 5 minus 1 would be 4. I think that's the correct ending spot. Yeah. And then if I go 2, if I go D is 2, then this is going to give me hopefully just the same spot. 6 plus 2 minus 2. It gives me 6. And then 5 minus 1 is 3. 5 minus 2 is 3. So 0, 1, 2, 3. So that gives me 8. And that would include one more thing if I had something there. Okay. Okay. Capping this thing at the minimum of this thing and the number of positions plus 1. And capping this thing at you know what, if I just extend out the array by K, that probably doesn't work because K could be very big. Never mind. Otherwise, like I could add a bunch of the same values at the end of the prefix so that even if I tried, I go out of bounds. But then the size of that K is just too big. It could be the size of the array. It could be, yeah. I And then this is going to be the maximum of this value in 0. Can't do negatives. Harvest right. Hopefully this is going to be easier. Oh shit. This is totally wrong. Prefix of this minus prefix of this. Okay. Harvest right would be going right d steps and then reversing it. So it would be prefix going right d steps. Going right d steps. So it would be going right 1 step. So start position plus 1 plus d. Or is it start position plus 1 plus? So we should be getting to 19. So yeah, start position plus 1 plus d. And then the other way is going to be start position minus k plus 2d. Start position minus k plus 2d. Minus k would be 4 plus 2d would be 2. So some start position is 5, so 0, 1, 2, 3, 4, 5 minus 2. So this thing, so I'm doing 19 minus 9. 1, 2, 3. Yeah, I think that's right. Minus k plus 2d. And then capping those as well. So the minimum of this thing and end position plus 1. And then the maximum of this thing 0. And the answer equals maximum of harvest left, harvest right, and answer. Maybe there's a better way of. This is a lot of comparisons. Out of bounds. Start position plus 1 could be out of bounds. Could it really? How is this out of bounds? Start position could be 8 plus 1. Start position could be 0. Oh, I see. The start position doesn't have to correspond to the fruit's positioning. I see. So I think the number of positions could be the maximum of the fruit's positioning and the start position. Yeah, I think that's right. Or I think that's what was the issue. Ooh, that's gonna be really slow. Yeah, that's gonna be really slow. Yeah. Is the fruit empty? What's going on here? If position equals f index. Oh, I reached the end of my thing. Reached the end of my thing. How to fill it out then? I could add a dummy fruits. that never gets reached. And then I wouldn't go out of bounds. Okay, fruits and I guess this can be a 2-element array that is infinity at position infinity, something like that. Yeah, this could be a lot faster because of this sparse possibility of use. Okay. Wow, it's a lot of errors. So I'm quoting, let's go error here. Just wrong answer. Okay. Should be 11. So let me go ahead and print out the stuff. Alright, start position is 7, K is 3. So I should be able to get 4 things. So from position 7, it's not hitting anything, it's between these two. The maximum should be 11, so I think maybe it should go left 1 and then right 2. Left 1, right 1 to get 6 plus 5. But I'm only getting 7. So I'm going strictly right, I think. 7, 8, 9, 10. Okay, reasonable. So from 7, I should be at 8 in this index. So 0, 1, 2, 3, 4, 5, 6, 7, 8, which is at 13. Yeah, I think that's right. So I guess I never got, you can go and print out harvest left and harvest right here. So let's say D, harvest left, harvest right. I guess neither of them actually worked correctly. D should only hit 1 maybe. So I don't think there's ever, D doesn't hit at all, I see. Okay, it should be K divided by 2 plus 1, I think. Or maybe K plus 1 divided by 2. If I have 3, yeah, should be K divided by 2 plus 1. So if it's 2, it would be 2 divided by 2, which is 1, 1 plus 2. If it's 2, then it goes 1. That's fine. Right now it goes 0. Okay, I think it should be plus 1 here. Okay. Oh, whoops. Probably need to get rid of this printout. Last executed output. Okay, yeah. There's just too many things in the array to print out. Oh boy. Well, we're not close to being fast. I think this thing would extend out as far as possible to show where I'm at in runtime, so I don't think this is great. Like it could be like the thousands and it still show me in the boonies of time complexity. But that is a solution. I think maybe this prefix sum, it might not be the thing. It hard codes the array amount, so it's easier to index. But maybe I should just be doing some sort of sliding window. Yeah, maybe I should be doing some sort of sliding window so that I don't have to actually calculate calculate the positionings of everything. Maybe. Okay, I'm going to spend some time optimizing for this. So if I didn't use a prefix array at all, pretty much is the optimization, because it could be very sparsely, like something like this, where you have one fruit and you have like one starting position. This prefix sum is actually going to create a whole 200,000 size array to mostly be 0 or no, mostly be 10,000. Whereas you could just maybe skip all that stuff. I assume this thing is actually kind of worse in memory as well. Okay, so I mean a prefix array is probably better if this was not sparsely located fruits. So how would that work? I think can I just do one pass? Could I do one pass? So if I try to one pass for just finding the full value going left and right, I could use bisect left to figure out what index I'm at. Shucks. Sure. So then I still need to have a sum. Okay, maybe I do need something like that is similar to prefix, but actually of whatever is there at different positions. Whatever is there at different positions. I guess that work. So for every position and the number of the value, the count of the fruits at this position in the fruits array, prefix, and whatever is the current count. I guess position doesn't matter at this point. So every count in fruits, I'm going to do the prefix currently plus the count. I'll have to figure out the indexing using other methods. And then if I want to harvest left, then let's say I want to use bisect left. Is it bisect left? the insertion point of where this position would be in the fruits array, I guess. Bisect left within the array of fruits. Start position. That might be off by. Does Python have a bisect right? I don't think it does. Maybe it does. Is used to find an insertion point for an element in a sorted list. It returns where the new element is inserted into the list to maintain sorted order. If the element is already present, it returns the index after any existing occurrences of X. Okay. I think I want bisect right here. Start position. Let's say 5. Let's see this. So the position here is 6. The start position, let's say, is 6. I'm finding 6 in this thing, so I want to have. Actually, let's go ahead and just print out the sum now. Why would this not be? Instance of int and list, I see. Okay, yeah, I think I need to have both the prefix sum for the counts and also the positions, places. I'll just let me write that, and I'll append. Should I have places of 0? Maybe I don't with 0. Prefix, no, fruits at 0. Okay, I guess I do need to have the position here. Okay, so let's go places for the start position. Okay. So actually, let's go and print out the places as well. So 2, 6, 3. If I have position 6 and I want to find it here, give me back index 1. But I want to include 6. So I think I want index 2. I think I want but then if it's 5, then it would be, if I search for 5, it'd give me 1. If I search for 6, it gives me 1 as well. So I need to make sure that 6 doesn't give me the same answer as 5 or 4. Yeah. So 6 gives me 1, or 0, 1, 6 gives me 2. Maybe I should start with, yeah, 6 should give me 2. What? 6 gives me 1, even if I bisect right? 0, 1. If the element x is already present, returns the index of after any existing occurrences of x. This means the element will be inserted to the right of all identical elements. Oh, start position is 5 currently. Shit. Let's go change this to be start position of which test case was I on? Test case 3? Okay, so yeah, that gives me 2. So if I search for 0, that should give me 1. Search for 5, that should give me 0, that gives me 1. 1, that gives me 1. 5 should give me 1. 6 should give me 2. Then if I have 8, then it's going to go out of bounds, isn't it? Oh, that's fine actually. 8 would give me 6, 7, 2, 3. 3, which is going to be 12 here. 6, which gives me 2. 2 is where this thing goes different than 1. Okay, I think that's maybe right in terms of what I want. Let's go ahead and just comment this stuff out for the time being. So then what I want to do is find just the baseline harvesting left and harvesting right if I move the full K amount. So it should be something like, so I don't mind if the position plus K or the position minus K is out of bounds in terms of the overall positioning, because here I'm just searching for the index that would be inserted in. So it's not going to give me like an improper index. Okay, so let's say I want to find position minus K, or is it position minus K plus 1? So if K is 1 and my positioning is 6, then do I want to find 5 or 4? 5 is going to be, I think I want to do bisect left of 5. I guess I could have also done bisect left of start position plus 1. Maybe that's better so that I don't confuse myself. Yeah, maybe that's better. Bisect left places start position plus 1. Because I want to include the current position. Yeah, okay. So the current position is that. Oh. Well, what happens if the current position? Oh, so if I go left, then so if let's say I do 6 and I do K is 1. 6, I do K is 1, then I just need to find 5. Exactly where 5 is. So I think it's bisect left of just position minus K. Left position is going to be bisect left of places, comma, start position minus K. 5. Is that right? Okay, let's go add a test case here. Let's say there's 5 and 10. And I probably want Oh, this here. Let's go left position, current position. Okay, so currently I do left is 3, 0, 1, 2, 3. No, sorry, this is the one. 0, 1, 2, 3. So it'd be at 17 and 1. So I'd be getting these two. 17 minus 3 is 14. 4 plus 10 is 14. Okay, I think that's right. Surprisingly. Okay, and then if I want to do right position, then bisect left. Is it bisect left or bisect right? Or bisect left of something plus 1. Places, start position, maybe plus 1 plus k, something like that. So I'm really trying to find 8. Start position is 6, k is 1. I want to find where 8 would be inserted. And then at that point, I want to have the bisect left of start position rather than start position plus 1, I think. Yeah, I think this is going to be incorrect on the positioning. If I were to subtract the prefix values. Yeah, this would be 22. I do need one more to be right next to it. So let's go test case 7, let's say 20. All right, so this gives me 5. 0, 1, 2, 3, 4, 5. Is that too much? Start position is 6 plus 1. I think that's too much. 0, 1, 2, 3. Or if it's not too much, then maybe I need something else, because then this thing is going to be not found. So it's just it should increase by 20. So it should be this one right here. 0, 1, 2, 3, 4 should be this one. Actually, I don't think I need plus 1 here, because it's inclusive of that value. So 0, 1, 2, 3, 4. So from 17 to 37 is the 20 spot, which is that spot. But then I'm not subtracting the correct number. So yeah, from that spot, I should be subtracting not position, but position minus 1 maybe. No. Yeah. Yeah. Hmm. Okay. So start position 0, 1, 2. 0, 1, 2. Maybe I just need to have this in the start position. So I'm trying to find where exactly start position is. Yeah. And this gives me 1, which is... This gives me 2, which is exactly where it is. I just probably need some logic that includes it or not includes it appropriately. So if this value, so 2, searching for 5 gives me 2, searching for 7 gives me 4. Searching for 7 gives me 4. I wonder. Is that right? If I didn't have the 7 there, searching for 7 should give me this spot. Would that be incorrectly spotted? Searching for 7 should give me 3, 0, 0, 1, 2, 3. So it gives me this spot before adding the 5. Yeah. Zero, 1, 2. 0, 1, 2, 3. So that is correct. Start position plus K. Alright, so I think this is farthest left. So oh my god. If the value at current position at start position, if the value, if fruits at current position, maybe I should say index, left index, start index, left index, and right index. If fruits at the start index, the position of it is equal to the start position, then so start position is 2. And this matches it. So I want to, so 2 minus 1, 0, 1, 2 minus 1 gives me just this thing. Just the 10. Okay. Then it should be something like harvest left is equal to prefix of start index plus 1 minus prefix of left index. So it'd be 2 plus 1, which is 3. 0, 1, 2, 3. 3 minus 1. So 17 minus 3 is 14, which is 4 and 10. Else, it should be prefix of start index minus prefix of left index. Okay. And then similarly, if I do right should be 3, 0, 1, 2, 3. So it'd be 17 minus 2 currently. 17 minus 2 gives me 4, which is just this thing. So it should be harvest. Right is equal to prefix of right index minus prefix of, I think, start index minus 1. So that includes 13, so it's 17 minus, wait, that's wrong. 17 minus 3 is 14, which is correct on the right side, but not correct on the left side, actually. Harvest right is prefix, right index, minus prefix of start index. Left side should be doing 13 minus 0. So this thing's 2, so 0, 1, 2. So 13 minus, actually, no, maybe I'm wrong. So 6 should be to 10. It should be 13 minus 3. Should be this value. And then it should be 13 minus 1 if it's, no. What am I doing? No, the first one was right. It should be 13 minus, no, 17 minus 3. The first one should be 17 minus 3. 14, which is, no, let me go ahead and just do the test case backwards. Put this thing back in here, 7. Wow. My math is really bad today. 4, I don't think this goes out of bounds. Or maybe it does, what the hell? I relabeled this. Left index, start index, right index. Fruits is equal to start position. What's wrong with that? Out of range? Oh, I see. Yeah. Start index is out of bounds. This is 1. There's no 1 fruits. Okay, so I think this should just be if start index is less than, or maybe I can make a dummy fruits here. Position infinity, and there's going to be 0 fruits there. All right. So here, position is 1, 2, and 4. So searching for 5 gives you 1. Searching for 6 gives you 2. Searching for 7 gives you 4. Oh, K is 2 here. What the hell? I want K is 1. K is 1. Okay, so 1, 2, and 3. 0, 1, 2. So if I do 2 minus 1, that gives me 4, which is just this value. Shit. So I think I need to do it's not really what I want. 0, 1, so 0, 1. Actually, 2 minus 1 is going to be 0, 1, 2. So 2 minus 1 is actually, no, sorry, it's gives me 10, so it gives me this value. So if 6 is there, then I want to have 1 more. So start index plus 1. Yeah, so it'd be 3 minus 1, which is 14, which is correct. And then if the 6 is there, then the other one is going to be the right index, which is 3. 0, 1, 2, 3. 17. No, it should be 4. If I insert 7, yeah, it needs to be inclusive of it. So the right index should be plus 1. Start position plus k plus 1. Okay. I don't feel great about how I'm just going through every single fucking test case to figure out whether or not it works. So 0, 1, so 0, 1, 2, 3, 4, so 37. 37 minus 2. No. It should be 37 minus the 13 to get 24. 0, 1, 2, 3, 4, but currently it's subtracting the wrong one. So we should subtracting start index. Yeah. I guess okay, that's if the start position is there. Does it matter if it's not there? If it's not there, then it should be start index plus 1. Oh my lord. There has to be a better way of doing this that doesn't involve me fucking going through every single index like this. Oh my god. I'm looking at this code and just my eyes glaze. If I wasn't like into the weeds, like really 5 feet into the weeds right now, I would be so disgusted trying to figure out what the hell's going on. Oh lord. Okay. Tempted to just delete everything here. This is just too edge casey. Would it be so bad if I just did a single pass? Would it be so bad if I did a pass? I mean, I'll have to do at least one pass to do the other stuff, right? Maybe I'm just trying to optimize too much to do this one calculation without doing a pass for it. I guess the other stuff would be doing a single pass here, so it's kind of doubling the number of passes that I go through for just this one calculation. It shouldn't be this hard. Okay. It shouldn't be this hard because I shouldn't be this bad at about finding stuff in a sorted fashion. Okay, so what's going on here? Places append positions. So places has all my positions. Prefixes all the sums of everything up to a certain index in places. If I want to have a sum of places of 0, inclusive of 0 or not inclusive of 0? Inclusive of 0. Inclusive of 0. What's going on? So if 0 has 3, I search for 0, I find index 1. I search for -1, I also find index. No, I search for, no. If I search for 0 here, I find index 0. If I search for -1, I also find index 0. But if I wanted to actually calculate how much I would get for a starting position of 0, even though 0 is found there, I would need to I would need to do that value plus 1, index plus 1. But if I do index plus 1, then that didn't work if I search for -1 and found 0. Okay, so then I'd be at the same index. I wonder if there's a way for me to fix this issue of like inclusivity and exclusivity. If I take the index that I find the position at, maybe I should just maybe I should just zero this out so I don't have to worry about it. What if I just thinking answer, let's say the baseline is 0 And if I ever find the position, the start position in my fruits, then the baseline is now equal to whatever number of fruits is there. What if I did that? And then I just and then I just remove it. So I don't have it in my calculations at all because it's already pre-calculated as to be gathered. So if position equals start position, base is equal to count, and continue. Otherwise, the count moves normally through that position. So I never have to deal with this shit. So this position is guaranteed to not be there. The start position. Could that work? Prefix append prefix -1 plus count places append this position. I don't see why it wouldn't work. Or I currently don't see why it wouldn't work. So I mean, in that case, couldn't I just also find the indexing without using this statement here? I guess this thing would add a constant amount of stuff. This is kind of a bummer that I have a constant amount of work added here. I mean, I am doing a pass here anyways. I am doing a pass here anyways. Okay, let's just too many ideas. So if I find my left index, I guess I still would find my start position here. I guess I will start this for every position. Okay, this is still fine. The start index is places, finding start position minus k, start position plus k. Okay, let's go ahead and just see what's going on here. Okay, so the positions here are now just 0, 5, 7, and 8. So 0 goes up to 3 to 10, goes up by 3 to 3, up by 10 to 13, up by 20 to 33, up by 5 to 38. And if I wanted to find 5, then it would be, or if I want to find 6, 6 is going to occur at 2, 0, 1, 2, and 5 is going to occur at 1, so 2 minus 1 is 10. If I want to find 7, 7 occurs at 3, 0, 1, 2, 3. 3 minus 6 is 20. Okay. Well, is that right? Did I find 7 or did I find 8? I found 8 because I wanted to include 7. 0, 1, 2, 3. Yeah, because I wanted to include the other one. If I didn't do If I didn't do it plus 1, then I think it would just return 2. 0, 1, 2. Yeah. This is the same thing as doing prefix or bisect right. So I think harvest left is now just equal to prefix of prefix I start index minus prefix of left index. Harvest right is equal to prefix of right index minus prefix of left index. And let's say answer equals, I guess I can print that out here. Print harvest left, harvest right. And a base, I guess. Harvest left is 10, harvest right is 30. Ooh, 30, that's not right. It should have been 20. Okay, so what's going on here? It did like 3 minus 1. 33 minus 3 should be 20. But, the right index should have been 3, 0, 1, 2, 3. 33, oh, it should have been minus 13. Oh, whoops, this should have been start index. What am I doing? Okay. So 10 and 20. Okay, next test case, I'll just delete the middle number. So let's say there's nothing at the start position. It should hopefully give me the same results, 10 and 20, but with a base of 0. Oh, hallelujah. Okay, I think I can get rid of this all this crap. Okay. So currently my answer is like here. My answer is initially the maximum of harvest left, harvest right, and the baseline. What's the base? Alright, so then it's going to go over the backtracking possibilities here. So this one I'm gonna use, guess I have to use a stack, no, probably a queue. Stack or a queue. So can I do it in one pass or can I have to do it in 2 passes? So so I do a single so what would it be? So if I think about let's say some positions 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's say my position is 5 and k is 4. So if I have that, then what I'm looking at is if I go leftwards and backtrack, be going left 2, so going down to 3, and then backtracking back to 5. or going leftwards 1 and back and going up to 1, 2, 3, up to 7. Or going 0 this way and 4 the other way. I guess maybe this all could be wrapped up in the same calculation rather than a separate calculation for harvest left and harvest right. So my window, so if I go up by 1 step here, then I need to go over by 2 steps there. So every time I go up 1 step on the left side of the window, my right side of the window can go up 2 steps. Oh, this is just a sliding window then for everything. Okay. So if I do for my left side of the window in range of start position minus k I think I need to have another value here. So it's going to be left side my left side of the window, yeah, it's going to be minus k divided by 2. Up to start position. Something like that. If k is 1, then I can only go 0. K is 2, then I can go 1. K is 3, then I can go 1, 2, 3, 3. I can go 1. K is 4, I can go 2. Yeah, I think that's the correct start position. If left is 1, then I go 0 to the left. This loop never executes. So I think maybe this should be, if k is 1, I go 0 to the left. Is that right? K is 1, then what do I want to do? I want to go 1 to the left at least. So I need to have k plus 1 divided by 2. If k is 3, then I'm going to go 2 to the left. Or should I go to start position plus 1? Maybe this should be start position plus 1, because the left side could include the current position. So yeah, start position plus 1. Okay. Maybe I should just do something like this in range of going from left 0 spaces and then 0 to k divided by 2. So it's just a number of steps rather than the position that I'm at. So I can do 0 steps to the left and the full k steps to the right, or 1 steps left and k minus 2 to the right. One step left, k minus 2 to the right. K minus, yeah. So my initial window needs to be set up though. My initial window needs to be set up. All right, I got it. It's been 2 hours. I guess I probably should take a break for this one. All right, so I think I'm gonna just wrap this thing up. My initial submission, which is, well, my initial submission that was accepted was this thing. So going over this, what was the actual idea here? Okay, so basically, this is kind of a slow solution. And eventually I'll figure out the fast solution using something besides a prefix sum, but this one, create a prefix sum, which is an array that sums up to the ith index, or the pth position for every position, every possible position. So that calculating the number of fruits to obtained between, let's say, positions A and B is equal to the prefix sum of B minus the prefix sum of A. This is kind of ignoring edge cases of inclusivity between A and B. Glossing over that, even though it's a pretty big matter of concern. But that was this part here. That's creating the prefix sum. And then note that the only possible the only ranges of positions to consider is based on the above. This thing, you can either go in one direction, left or right, that direction, that k steps, or you can go in one direction, x steps, and the other direction, y steps, where like 2 times x plus y equals k, or basically if you go 1 step in this thing, you have to go 2 steps in the other way, and 2 times 1 plus 2 is equal to 4, or something like that. Then iterate over possible places for left and right edges of positions, finding maximum counts for sum of fruits in this range using the prefix sum, prefix array, and then return the max. So that was this thing here. For every step D in one direction, I found how much I can harvest if I go left that amount of D and then right like k minus 2D. Where is this? K minus 2D. Guess I can't extend this thing using. Wow, can't even see it. And then the other thing, going right D and then going left k minus 2D steps. And then returning that answer. And then time complexity is going to be O of n, where n is the number of steps, number of positions, and this is worse than O of n, where n is the number of fruits. So this could be optimized, should be optimized to be n equals number of fruits, number of positions, rather than the number of total possible number of positions, max positions. But anyways, I'll try to optimize it at some point. Space complexity is going to be O of n, where n is the max positions again.